Hello, Integrating Man here. What I have for you today is the integral of dx over a plus b cosine of x, where a and b are constants and real. The way to do an indefinite integral of a rational function of cosines or sines involves a transformation that isn't obvious at all, but amazingly works out. So I'm going to go ahead and do that. There are other ways you could probably do this as well, but this is kind of a neat transformation. So, transformation, we're going to consider tangent of 1/2 of x and set that equal to a constant t. See if I can get this a little bit better. Good. Then we can write, we know that sine squared of 1/2 x plus cosine squared of 1/2 x is always going to be 1, right? So let's go ahead and divide this equation by cosine squared of 1/2 x. So I get tangent squared of 1/2 x is equal to, or plus 1 is equal to 1 over cosine squared of 1/2 x. Well, this is 1 plus t squared on this side. That's equal to 1 over cosine squared of x over 2. Well, let's go ahead and apply the double angle formula. So cosine squared of x over 2 is the same thing as 1 plus cosine of x, quantity divided by 2. So that would be 2 over 1 plus cosine of x. All right, so 1 plus cosine of x is going to be equal to 2 over 1 plus t squared. So I'm going to box this. We'll keep that in mind. Then I also know that if I divide through by sine here, the sine squared of 1/2 x, that I'll get 1 plus 1 over t squared is equal to 1 over sine squared x over 2. And then the double angle formula becomes 2 over 1 minus cosine of x, or 1 minus cosine of x is equal to 2 over 1 plus 1 over t squared, or 2t squared over t squared plus 1. All right, now let's go ahead and figure out what cosine of x is in terms of t and what sine of x is in terms of t. So I'm going to remind this. So cosine of x could be written as 1 plus cosine of x minus 1 minus cosine of x, whole thing divided by 2. The ones cancel out and I get 2 cosine of x. Let's apply that. So this would be equal to 2 over 1 plus t squared minus 2t squared over 1 plus t squared, whole thing divided by 2. So this is just 1 minus t squared over 1 plus t squared. So that's cosine of x. You can also easily figure out what sine of x is. Recall 1 minus cosine squared of x, which is 1 plus cosine of x, times 1 minus cosine of x is sine squared of x. So let's go ahead and apply this. And this is, so I get 1 plus t over 1 plus t squared times 2t squared over 1 plus t squared is equal to sine squared of x. This is 4t squared over 1 plus t squared squared. Taking the square root, I get sine of x is equal to, and then I'll have a plus or minus 2t over 1 plus t squared. If you're careful about our transformation and look where sines and tangents are positive, I think you'll find that this will be a plus sign. One other thing that will be useful will be just to know what dx is. So if we have tangent of 1/2 x is equal to t, let's take the differential of both sides. So dt is equal to 1/2 secant squared of 1/2 x dx. Now, this is just cosine squared of 1/2 x. Well, I'll just write this out. This is 1/2 2 over 1 plus cosine of x dx, right? Plugging that 1 plus cosine of x is 2 over 1 plus t squared. I get 1/2 2 over 2 times 1 plus t squared dx. So canceling these twos out and dividing through by 1 plus t squared over 2, I get that dx is equal to 2 dt over 1 plus t squared. One more little bit. Now, we can go ahead and substitute this into our integral. I did the sine one, maybe we'll use that in a future integral. Let's go ahead and just apply that. So this integral becomes the integral of 2 dt over 1 plus t squared, that's dx, times a plus b, and then cosine of x is just 1 minus t squared over 1 plus t squared. And so I will evaluate that t integral and then substitute variables at the end. Let me go to another page so I can do this. So the integral with respect to t is then going to become the integral 2 dt 1 plus t squared a plus 1 minus t squared b. Okay, so I is equal to that. Let's get all like powers together. So this would be the integral 2 dt of a minus b t squared plus a plus b. Let's go ahead and factor out a 1 over a plus b. So this is 2 over a plus b times the integral of dt over a minus b over a plus b t squared plus 1. Let's go ahead and we'll change variables so that a minus b over a plus b t squared is equal to u squared, which would mean that u is square root, say, of a minus b over a plus b t. So dt is square root of a plus b over a minus b du. Let's go ahead and substitute that in. So this integral is equal to 2 over a plus b square root a plus b over a minus b integral du over u squared plus 1. Hopefully that integral is fairly clear. That's the arctangent of u. I can clean this up just a little bit. This is 2 over the square root of a plus b over a minus b, which is a squared minus b squared. Arctangent of u, which is the square root of a minus b over a plus bt, and t is the tangent of 1/2 x plus an arbitrary constant. So that's my integral. In any case, that's all I have for you today. If you like this, please feel free to like or subscribe. And in any case, have a good day.